Hello guys and welcome back to a new video. Today we will find what sine of I is equal to, and I is the imaginary unit, so the complex number thing, and it is not common to find I inside the sine function, but yes, this is possible and it has a solution. And the solution, if you type sine of I in Wolfram alpha, is 1.752 times I, and this is also equal to the hyperbolic sine of 1 times I. Now, don't worry if you don't know what hyperbolic functions are, because we won't need them in this video, but we can find sine of I by hand. So this is what we're trying to do, and we can do it in a few steps. So how can we proceed? Well, firstly, we need to know what sine of a complex number is. Now we start with an equation I'm sure you're familiar with, and this is this identity here: e to the I theta equals to cosine of theta plus I sine of theta. Okay, this is how we can write this combination of cosine and sine, or basically any complex number, in polar coordinates, and we can represent it using an exponential. This comes from Taylor series, but we won't derive this equation now. Now the problem is, or at least it seems a problem at first, that theta is a real number and I is the imaginary unit. But we need a complex number inside the sine. We don't need a real number. So, well, I can tell you that by definition, we can plug complex numbers instead of theta, and this is by definition. So we will use this equation from now on. Okay, so we need to sort of isolate sine of theta from this equation, and we can do it in the following way. So let's take e to the I theta, and let's subtract from this quantity e to the minus I theta. You can guess this in a couple of seconds just looking at the equation. It's not complicated, but let's write e to the I theta. This is cosine of theta plus I sine of theta. And from this quantity, we're subtracting, so let me put a minus sign and open a bracket, e to the minus I theta. So we need to change the sign of theta inside the trigonometric functions. So cosine of minus theta plus I sine of minus theta. This is what we're doing. Let's close the bracket and let's compute this quantity. So the first part is unchanged, so this is cosine of theta plus I sine of theta, and the second part actually changes a bit, because cosine of minus theta is cosine of theta, then we also have a minus sign in front, so this is minus cosine of theta. Instead, let's ignore this I in front. We don't care about it at the moment. It's just a factor in front of sine. Sine of minus theta is minus sine of theta, but we also have a minus sign in front of it, so minus times minus is plus. So this is plus I sine of theta. And we can happily cancel out cosine of theta and minus cosine of theta. So this equals to 2I sine of theta. And we can do another thing. We can move this 2 to the other side of the equation, just divide both sides by 2, and we can also move I. But firstly, let's move the 2 to the other side. So we have, let me use the green color, e to the I theta minus e to the minus I theta over 2. This equals to I sine of theta. But we have to move I to the other side of the equation. And we can do that by multiplying by minus I both sides. So let me do that. Minus I, and here we have minus I. In this way, on the right hand side of the equation, I squared equals to minus 1, but we also have a minus in front. So this is minus I squared sine theta. This quantity is minus 1. Minus times minus is plus. So we get sine of theta. Let me write it here. Sine of theta equals to minus I e to the I theta minus e to the minus I theta, all divided by 2. Now remember, the theta can also be a complex number. In this case, we're interested in I. So let's put I instead of theta and let's see what happens. So minus I e to the I times I. Then we have minus e to the minus I times I again, all divided by 2. And this is equal to sine of I. Now, this is I squared, and we said earlier that I squared is minus 1. This is also I squared, and it is minus 1, but we have a minus sign in front, so overall it is plus 1. So this quantity here is minus I times 1 over e, because it is e to the minus 1, minus e to the plus 1, so I won't write anything, all divided by 2. And this is the answer to what sine of I is equal to. This is the analytical answer. Then you can take a calculator and find what this quantity is equal to, and we will find that it is equal to roughly 1.7520, etc. And how cool is this? We found what sine of I is equal to, and it's an imaginary number. Now, in another video, we will find what cosine of I is, and cosine of I instead is a it's a real number. It is not an imaginary number. So I think it's cool to find this result. So if you enjoyed this video, don't forget to subscribe to my channel, leave a comment down below, and like this video and share it with your friends, and see you in the next video. Bye.